This video is going to start chapter 4, which is systems of equations. So 4.1 is going to introduce us to what those are. A system of equations is a set of two or more equations that we end up plotting or graphing on the same grid. And the solution is where those lines, if they're linear, but where the graphs intersect. Where they intersect. Parallel, again, those lines have the same slope and never touch. So they're not going to have a solution. There's no solution to parallel lines because they never cross. We refer to those as inconsistent. So these ones are parallel. They never cross, so they're inconsistent. They're never the same, inconsistent. Intersecting lines cross in one place, so they have one solution. That's this pair. That one point is their solution. They're called consistent because they have one spot where they're the same, but they are independent. Independent. That rating's terrible, but it's independent is what that says. And they're independent because they only cross at that one spot. Other than that, they're their own thing. Okay, consistent, independent. Okay. Then finally, if the two end up being the same line, they have infinite solutions. Meaning, if this is one line and this is the other line, they cross at every possible point. So they're infinite. We have infinite solutions. And then they're consistent because they're the same, and they're dependent because they're the same at every point. So inconsistent or consistent, and then independent is one point, dependent is multiple. If you're deciding whether a point is a solution, plug it into the equations and see if it's true. In order to be a solution, it has to make both true. So let's look at 4, 6. 4 is x, 6 is y. If I plug them into this one, 4 plus 6 equals 10. That's true. Now we'll plug them into the bottom one. 4 minus 6 equals 4. Well, 4 minus 6 is negative 2. That is not 4. So this is not a solution. It doesn't work in both equations. Not a solution. Now let's try 7, 3. If I plug that in, 7 plus 3 is 10. That is accurate. And 7 minus 3 is 4. That is also accurate. So 7, 3 is a solution because it works in both equations. On a graph, we would just find the point they intersect. If you didn't have the graph, like let's pretend that's not there, we're going to solve these so they say y equals. So I'm going to take this one. X plus 2y equals 4. I'm going to move the x over. Oh, hit a button. 2y equals 4 minus x. Divide everything by 2. Y equals 2 minus 1/2 x. If I were to draw that, start at 2. Start at 2. Go down 1 over 2. Down 1 over 2. We have that line. Now let's do the other one. I'm going to subtract 2x from both sides. Negative y equals 3 minus 2x. Divide everything by negative 1. Y equals negative 3 plus 2x. So to graph that, we'd start at negative 3. And we would go up 2 over 1, up 2 over 1. And we have that line. The point where they cross, 2, 1, would be our solution. If we plugged that into both equations, it would work. If we graph them, it's where the lines cross. That's how that works. Get rid of that. Okay. Word problems. I don't know what I did. Shrink. Word problems. Okay. So we can use those word problems to make two equations and then solve. So let's read this. Of American adults who don't use the internet, about 33% are either just not interested or don't have a computer. We don't know which is which. So let's say X is not interested and Y is no computer. And if we put those together, we get 33%. That's how we're going to use that sentence. The next sentence, there are 7% more adults who are just not interested than those who don't have a computer. So if we were to subtract those, there's more just not interested. So if we did X minus Y, we would get 7, meaning X has 7 more than Y. Now we have our equations. We can use the calculator to graph them and find an intersection. So the first one, X plus Y equals 33. If I subtract X from both sides, I get Y equals 33 minus X. For the red one, I'm going to subtract X. Negative Y equals 7 minus X. Divide everything by -1. And I get Y equals -7 plus X. To put those in the graphing calculator, we're going to hit the Y equals button, top left. In Y1, we're going to type 33 minus X. And in Y2, we're going to type -7 plus X. Now that those are there, we can hit graph. We don't see any intersections, so that means it's not really zoomed well. So if I hit the zoom button, and then I go to 0 for zoom fit, it's going to show me everything in there. If I turn off the stat plots from the other day, so if yours aren't on when you do zoom fit, same thing, we just won't have those other weird dots. So zoom 0 is how you fit it to your equations. Now the calculator will find that intersection point for you. You're going to hit second, which is the blue button. You're going to hit trace, which is in the top row close to the right. So second trace. And then we're going to choose number 5, which says intersect. On your calculator, once you choose 5, you're going to hit enter, enter, enter. The first enter is going to choose one of the curves, one of the lines. It'll say first curve at the top instead of where mine says left bound. Then it'll do the same thing. It'll say second curve and you hit enter. And then it'll say guess and you hit enter. And then it'll spit it out. So this one's just a little different because it's a program. Guess. So down here at the bottom, mine says X equals 20, Y equals 13. Yours would have on the screen, it's going to have the graphs, and then it'll say X 20, Y equals 13 down in the bottom. Those are the coordinates of the intersection point. So your calculator will do that for you. We'll get more into this in 4.2, but let me know if you have any questions.